This is our quadratic formula, and it can be used to solve any quadratic equation. With the plus or minus there in front of the radical is how you get your two separate roots. Okay, with this first example, I've got the quadratic formula again in the corner to help us out. First, we need to identify a, b, and c. Remember, a is in front of the squared. We don't have a v, so that's basically a 0v. That would be your b, and this would be your c. So for the first step, I'm going to plug everything in exactly into the formula. All the b's are going to be changed to 0, all the a's to a 5, and all the c's to a 1. Okay, since b is 0, we put negative 0 plus or minus b squared. So 0 squared minus 4 times a, which is 5, times c, which is 1, all over 2 times a, which is 5. Now that I've got everything plugged in, we start simplifying and solving. Now we know that adding 0 to something doesn't change anything, so we can take that 0 off. Same thing with the 0 in here. Subtracting 0 isn't going to change anything. So that leaves us with negative 4 times 5 times 1, which is negative 20. And then 2 times 5 is 10. Now we want to simplify our radical the best we can. We know we need to take an I out because it's negative. And then we can come over here to the prime factors. You get 2 times 10, 2 times 5. So a pair of 2's come out. I'm going to put that in front of the I. A 5 stays in the radical. And then it's over 10. And then one last step, we know 10. So 2 divided by 2 is 1. So we just put I, because we don't put 1i, radical 5. 10 divided by 2 is 5. So I radical 5 over 5 and negative I radical 5 over 5. And the braces are to show our set notation since we have a set of answers. Before we can identify A, B, and C, we do need to get everything on the left side. So we need to subtract this 10r here. And then when writing it, you want to make sure you put it in the correct order. Now another step you can do to simplify things, but that's not absolutely necessary, is take out a common factor. That'll give you smaller numbers to work with. Because we see all of these are divisible by 2. So that leaves me with 2r squared minus 5r minus 12 equals 0. Okay, now we're ready to plug it in. Here's our A, our B, and then this is over. Now we're ready to plug it in. So x equals negative b, so negative 5 plus or minus b squared, which again is negative 5, minus 4 times a, which is 2, times c, which is negative 12, all over 2 times a, which is 2. So now we'll start simplifying. And negative 5 is actually a positive 5. 5 squared is 25. Negative 4 times 2 is negative 8 times negative 12 is positive 96. And then 2 times 2 is 4. And then 25 plus 96 would be 121 over 4. Okay, and then we know the square root of 21 is 11. So we have 5 plus or minus 11 over 4. At this point, we need to split this up so that we can solve them separately. So 5 plus 11 over 4, 5 minus 11 over 4. 5 plus 11 is 16 over 4, which is 4. 5 minus 11 is negative 6 over 4, which reduces to negative 3 over 2. So 4 and negative 3 over 2 are your two answers. Okay, again, we need to get everything to the left side so that we can identify our A, B, and C, which means the 6K needs to be moved. And I'm going to line it up with the like term over here, and the 1 needs to be moved. That'll cancel that, making this side 0. So 11K squared plus 16 minus 6 is 10K. Negative 11 plus 1 is negative 10. So now we're ready to plug it in. We have negative b, which in this case is 10, plus or minus b squared, which again is 10, minus 4 times a, which is 11, times c, which is negative 10, over 2 times a, which is 2 times 11. And now to simplify, negative 10 stays negative 10. 10 squared is 100. 4 times 11 is 44, times 10 is 440, and it's all positive, all over 22. Now 100 plus 440 is 540, all over 22. And then let's see if we can simplify 540 by doing the prime factors. You get 2 times 2 is 70. 2 times 135, which is no longer divisible by 2, but we can do 3 now. You get 45. 3 times 15. 3 times 5. So we have a pair of 2's and a pair of 3's that can come out. So negative 10 plus or minus 2 times 3 is 6, and then there's still a 3 and a 5 inside, which is 15. Okay, now if you'll notice, the negative 10, the 6, and the 22 are all even. You need to check all 3 spots because there's 2 separate terms on top. But since all 3 of those are divisible by 2, we'll divide all of them. So negative 10 divided by 2 is negative 5. 6 divided by 2 is 3. And 22 divided by 2 is 11. So you have negative 5 plus 3, radical 15 over 11. And negative 5 minus 3, radical 15 over 11. So where does the quadratic formula come from anyway? Well, it comes from completing the square. As we go through that process, which is A, B, and C, we'll see how the quadratic formula is formed. So I will show you. First, we have to get C on the right. So you have ax squared plus bx equals negative c. Then we have to divide everything by a. So x squared plus b over a x equals negative c over a. Then you have to add 1/2 b squared to each side. Well, in this case, b is b over a. Squared would be b squared. 2 squared is 4, a squared. So we add b squared over 4a squared. Okay, now to add these, we need a like term. This already has an a, it needs another a and a 4. So we'll multiply the c times the a and a 4. Multiply the bottom by a and a 4, which will give us like terms. And then we're going to move the positive first. So it would be b squared minus 4ac. And then now that they're like, we can put it under one denominator. Okay, and then on the left side, we want to factor this perfect square trinomial. So the square root of b squared over 4a squared would be b over 2a. And then we're going to square that. Now when we do the square root, you can't do the square root of the top, but you can do the square root of the denominator. It would be 2a. And then the top is going to remain b squared minus 4ac. We'll put a plus or minus in the numerator. Now we need to subtract the b over 2a. Notice they already have common denominators, so it's negative b plus or minus b squared minus 4ac all over 2a, which is our quadratic formula.